Large language models are incredibly powerful, but they often suffer from a silo problem. They are effectively trapped in a black box, unable to see your local files, your private databases, or live web services without custom-built, complex integrations. This is where the Model Context Protocol, or MCP, comes in. Think of it as a universal translator for AI. Instead of developers writing unique code for every single data source, MCP provides a standardized way for AI models to securely reach out and understand the world around them. It moves us away from fragmented, one-off connectors and toward a world where your AI assistant can seamlessly interact with any tool or dataset that speaks the same language. By standardizing how context is shared, we ensure that the model always has the most relevant, real-time information at its fingertips. To understand how MCP functions, we need to look at its three main components: the MCP host, the MCP client, and the MCP server. The host is the primary environment where you interact with the AI, such as a chat interface or a code editor. Inside that host sits the MCP client, which is the part of the software that initiates requests and follows the protocol's rules. Finally, the MCP server is a specialized application that sits directly next to your data. This server might be connected to a local folder on your hard drive, a professional database, or a cloud-based API. This architecture is brilliant because the AI model itself doesn't need to know the technical specifics of your data source. It only needs to know how to talk to the MCP client, which then handles the heavy lifting of communicating with any number of specialized servers. Within this framework, MCP defines three primary ways the AI interacts with information: resources, prompts, and tools. Resources are essentially read-only data, like a text file, a documentation page, or a log entry that the model can pull in to gain context. Prompts act as reusable templates that help the model understand how to structure its thoughts or queries for a specific task. But the real power lies in tools, which allow the model to actually perform actions. A tool might allow the AI to execute a piece of code, search a specific web index, or update a record in a project management system. This distinction is vital because it gives developers granular control over what the AI can see versus what it can actually do. It transforms the AI from a passive observer into an active participant in your digital workflow. Perhaps the most significant advantage of the Model Context Protocol is its focus on security and the creation of an open ecosystem. Because the protocol is standardized, a single MCP server can be used across many different AI applications without rewriting any logic. This creates a plug-and-play environment where the community can build and share servers for everything from Slack to GitHub to local spreadsheets. Security is baked in because the user remains in control of which servers are active and what specific permissions they have. Instead of giving an AI model full, unmonitored access to your entire computer, you are granting it specific, audited pathways to the information it needs. This balance of flexibility and safety is what makes MCP a foundational step toward more capable, reliable, and trustworthy AI agents.